Because I said what was on my mind. I made a lot of enemies. I made a lot of enemies.
Welcome, everyone, to In Defense of Climate Change. I'm Bryce Nickels, a professor of genetics at Rutgers University, and I'm joined once again by Roger Pielke Jr., who's a senior fellow at the American Enterprise Institute, professor emeritus at the University of Colorado Boulder, and author of the popular science policy substack, The Honest Broker. Roger's work focuses on the intersection of science, policy, and politics, particularly in the areas of climate, energy, innovation, and sports governance. Roger, how are you doing today?
Great. Good to see you, Bryce.
Today, I am excited to be talking to you about a new resource which you have created, which is called the U.S. Extreme Weather and Climate Change Dashboard. Before we get into what exactly this is, I wanted to talk about what motivated you to do this.
Let me start at the beginning, or at least a long time ago. In the 1990s, along with a NOAA scientist, Ken Kunkel, and an old school climatologist, Stan Shagnon, who passed away a long time ago, we did a paper on trends in indicators of extreme weather in the United States. It was published, I think, 1999. And what we did is we just summarized across heat waves, floods, tropical cyclones, hail, extreme heat, what the data record said. Even back then, almost 30 years ago, people were starting to become interested in trends in extreme weather. It was an enormous project, took us a couple years to assemble all the data. And one of our indicators, the heat wave indicator in that paper, for whatever reason, became an official indicator of climate change for the U.S. government. The Environmental Protection Agency, EPA, used to have a website where they would post data like this. And ours was used there. And I've long thought, boy, wouldn't it be great to have a better resource to track what the data says? Recently, last December-ish or so, the Trump administration decided to take down even this small amount of data for whatever reasons. And that got me thinking, if no one else is going to do it, the U.S. government's not going to do it, I should do it. And so it's taken me a while. I've gotten to be somewhat conversant with Claude code and the ability to manipulate enormous amounts of data very quickly. And so I decided I'm going to create a dashboard that just shows the data, and people can explore it as they like.
Can you speculate, or would you care to speculate on why the administration chose to remove some of this climate data?
Yeah, I mean, my sense is, and I don't have any inside information, but my sense is that the Trump administration has a very bad allergy to the notion of climate and climate change. So anything climate is verboten in their world. So as is characteristic of this administration, the baby goes out with the bathwater. There are certainly things like the National Climate Assessment that could be improved, but just taking down data wholesale is not a particularly good idea. So I just think this is part of the sledgehammer approach that the Trump administration takes to the climate issue.
Have you tried to reach out to anybody at the EPA or anybody in the administration to explain to them why this might be a situation, like you say, throwing out the babies with the bathwater, and maybe we don't need to throw all of this out?
No, I have not. I don't have good connections at a level that would make a difference, I think. And my view was my time's better spent doing it right myself. If the U.S. government wants to emulate or copy my dashboard, more power to them, and I'll help them out. But the data that I present is all official government collected data, mainly from NOAA, and props to them because open science is good science. And I'm just taking publicly available data and processing it and presenting it in a way that a normal person could understand it.
A lot of this data, wasn't this taxpayer funded, collected with, U.S. taxpayer dollars, right?
Exactly. All of it is taxpayer funded based on, the work of literally thousands of scientists over many decades. It's an incredible resource, and it deserves to be out in public.
Who is the intended audience for this dashboard?
So the intended audience is everyone who has an interest in extreme weather. So there could be, just Jane Public or Joe Public out there who wants to know what's the truth with respect to the time series of extreme weather. It could be people in insurance or reinsurance who actually make decisions based on understanding the data and trends. Could be journalists. And one great irony of this issue is, as everyone knows by now, extreme weather has become deeply politicized. And it turns out what people believe about extreme weather is a function of their political beliefs. And as you said, the data says what the data says. Not a day goes by that I do not see misinformation in the media about extreme weather events. And for some people, it's kind of a horseshoe theory of politics. Some people on the right, climate change is a hoax; it doesn't exist. And then for some people on the left, every event that happens is caused by climate change. And both of those views are deeply contrary to what the science actually says. And so what I'd like to do is just put the data out there for people who, care about data and would like to see what the data actually says, and maybe hold their, Wall Street Journal, New York Times reporters accountable when they put misinformation out there about the latest event was caused by climate change. Let's just put it into context. The reality is that some phenomena are changing and many are not. We can deal with that complexity.
I think that's an important issue to raise with respect to the Trump administration, because certainly the Trump administration has been, very clear, and I agree with them, and you agree with them, frankly, about how much misinformation there is around this issue. And so, in some ways, it would align with the brand of the Trump administration to put some of this information, or all of it. I guess I'm not sure exactly how much they took off the websites, back on, so that the public and the media can have access to essentially the data and the truth. So that to me is, I guess, what I would urge if anyone, is listening to this that has any. I mean, you laugh, Roger, but I'm telling you, like, all the Trump administration's watching this.
Well, then I would tell them, if I could speak to them, if they're watching, hello guys, this is the baby with the bathwater sort of problem. So if the Trump administration is interested in accurate information on extreme weather, then why not put the data out there that shows the claims that they've been making? And Chris Wright, who's the Secretary of Energy, has put out a report for years, from the time before he was in the Trump administration, with accurate information on extreme weather. And I would think that it would be in the interests of the Trump administration to put this out. So part of the problem, as I see it, is that once you start promoting accurate science, there is some accurate science the Trump administration doesn't like. Climate change is not a hoax. And so when the president says it is a hoax, it makes it very difficult to put out a nuanced message that, yeah, climate change is real, but not everything is climate change. There's somebody in the administration that doesn't like part of that message, so we don't get any of the data.
Is it fair to say, though, that, I mean, certainly that line, like, climate change is a hoax, perhaps just to sort of, I don't know if I'm, like, defending or being a devil's advocate here. I think the extreme effects of climate change are indeed a hoax, right? I mean, you've made that point. Like, the extreme scenarios are not, grounded in reality, right? Like, the idea is that there is nuance to this issue, and that there is climate change. Man's activities are causing the climate to change, and that's just, you know, true. It's just the extent to which the climate is changing based on man's activities and what we should do about it are where this sort of politicization is happening. Is that a fair assessment?
Yeah, that's fair, and that's very nuanced, and that's not the message we get from this administration, who has pulled the U.S. out of the Paris Agreement, has defunded the work on the Intergovernmental Panel on Climate Change. Um, so yes, I would love for there to be a nuanced message as you just articulated it, whether it's coming from the Trump administration or the Biden administration or whomever. Our policy representations of climate change have become much flatter over time, and all nuance has been sapped out of the issue. And it's kind of a red team, blue team sort of thing, like either on this side or you're on that side. And unfortunately or fortunately, climate doesn't conform to that sort of bipolar approach, I guess.
Right. I mean, like I said before, it's sort of like the middle or the is
Right.
boring. It's boring. The truth is boring in this case. Like
Yep.
it's sort of like, yeah, it's happening and, man's activities are contributing to it, but it's not going to destroy the world. But
It's
you
politically boring, and for policy and science, it's fascinating. And so that's a difficult mix.
Okay, so let's go into the actual dashboard itself. I had a question about the statement that you make on this that says this dashboard follows the IPCC framework for detecting a change in climate in the context of internal variability. Can you explain what that means?
The IPCC, Intergovernmental Panel on Climate Change, for since the start, has operated using a framework of what's called detection and attribution. And so this gets back to what is climate change in the first place. So climate change, it's not a causal actor. It's not something that makes things happen. Think about climate change like you would think about a change in a baseball player's batting average. So last year, um, Joe Yankee was batting 225, and this year he's batting 265. And you could say he's had a batting average change. Climate change is a statistical description of changes in variables that we associate with the climate. So temperature, precipitation, the number of hurricanes, the number of tornadoes, and climate varies over time. This year, for example, the Atlantic is dead. There are no hurricanes out there, and partly because of El Nino. We could talk about that. But in other years, the Atlantic is hopping, and there's plenty of storms. And so you can't take a short time series and say, well, from 2015 to 2025, we saw an increase, so the climate has changed. It doesn't quite work that way because there's so much variability. So the IPCC has a framework for detecting change. And what the IPCC says is that change in the statistics of weather and climate has to be greater than what we would expect from just year to year, decade to decade, ups and downs in the climate system. And they say formally that they want it to be less than a 10% chance that occurs just due to variability. And so that gives us a quantitative metric to identify changes in climate. Now, extreme events are a really difficult place to look for changes in climate, most importantly because there's so few of them. Think about it like if we're playing poker or blackjack, and I stack the deck. I put in a couple more aces. Um, you would have to play a lot of hands before you would have statistical evidence that the deck has changed. Many hands, and so looking for climate change and extreme weather actually happens to be one of the more difficult places to see that signal. Um, After a change is detected, so we go through the complicated statistics, we look at variability, and we say, yeah, heat waves have increased. The next step in the IPCC framework is attribution. All right, so why? Why is it that we see that detected change? Greenhouse gases are one factor that humans introduce into the climate system that changes the energy balance and can lead to changes. But there are others also, and a big issue that scientists are currently talking about is the reduction of aerosols, or more colloquially, the reduction of pollution. We used to burn a lot of coal. It was dirty. It would make the atmosphere smoggy, and the sun would get reflected, and that had an effect on the climate system. Things like irrigation and changing the land use patterns also have an effect. There's other greenhouse gases besides carbon dioxide, and on and on. And attribution requires the use of climate models to try to disentangle the different factors that lead to detected changes. And just to be very clear, my dashboard is only about detection, only about identifying whether a variable has changed. It's not at all about attribution, explaining why that has occurred. One of the biggest fallacies or traps on talking about climate change, and you see this in the media all the time, is that when people see that there's a trend in a variable, so if you start your time series of hurricanes in the 1970s, which was a low period, and you go to the 2020s, you're going to see an uptick in Atlantic hurricane activity, guaranteed in most metrics. Um, but that's not a detected change. And it certainly isn't a change that you can say, all right, we're going to attribute that to greenhouse gases. You can't make that leap. So my dashboard is all about what do the data say, and where do we have changes that have been detected.
But Roger, it does say here, what is this tab here says detection and attribution. So you just said it doesn't cover attribution,
Right.
but
I explain what attribution is, but I make no effort to perform an attribution because to understand the
okay.
IPCC framework, you need to know the two go together.
I see. So this is just meant to provide an explanation for how one would attribute any
Exactly.
change to something, but you're not showing that here yet. Is it, do you think in the future that you would try to potentially do that, or is that something that you want to leave to others?
Yeah, for now, it's leaving it to others because it does require a lot of modeling. It's complex. There is probably going to be a place to do a more comprehensive review of literature that purports to do attribution and comprehensively describe what's found in that literature. But attribution is a much bigger, more involved step than detection.
Okay. So do you want to go through some of the categories or like talk about how many different types of, uh, uh, data that you are presenting on this website?
Yeah. So what I've done is I've selected the um, extreme weather phenomena that have the greatest societal impacts. And think of that as human impacts, either loss of life or displacement, or economic impacts, the direct damages from events that come and like a hurricane, destroys a community or a tornado. And I don't have it on this site. I have a parallel site that I'm going to be releasing very soon on global weather. But these phenomena, you can think, account for something like 99.7% of all economic losses and human losses. So that's why I picked these phenomena. They're also the ones that people talk about the most. And so they're the characteristic megafauna of extreme weather. And that's why they appear on the site.
Okay, so if I go and I want to learn more about the trends in heat waves in the US, I would just come here and it says, so heat waves, it says 8.8 days. What exactly, do you want to explain what all these numbers mean? I mean, obviously tornadoes, like that's a total number of tornadoes, but heat waves mean, what is 8.8 days in relation to heat waves?
If you look right above that, there's 38 variables associated with 8 types of extremes.
Okay.
And if you scroll down just a little bit to the detection of
Uh,
long-term change. All right. In the upper left there in that panel, it says heat waves, detected change. So heat waves are increasing. If you click on that, that'll take you to the heat wave dashboard. And you'll see at the top there are 6 different metrics of heat waves. And it turns out this is one of the reasons why climate is fascinating and interesting. A heat wave, colloquially, we know what it is. It's hot. It's hot outside, and it lasts for a little bit. But in doing research, and you want to understand time series, you have to quantify what that means. And so, what you see here is that there are the different variables that we can put together. And let me be clear: these are not the only variables that we could invent to describe heat waves. And so, there is. The hottest day of the year. There's a heat wave index. This is the one that I mentioned earlier that came out of our 1999 paper, which measures 4-day extreme heat. There's the annual maximum high daily temperature. There's warm spell duration. So how long is it warm? Another way to measure heat waves is just what happens at night. And then uh, another complication is that data sets are variously adjusted by researchers over time to account for biases that they think exist there. And so, what I try to do on this site, across the site, is to be sensitive to the fact that there are multiple variables that are used to describe these phenomena, and researchers have different approaches to the data that describe those variables. Uh, so, so I'm trying to be as comprehensive as possible. If you look at that middle column there, you'll see some of the results are depend on what data set you want. Some of the data sets show an increasing amount of heat waves. One of them shows a decrease in their measurement. Uh, by putting all this together, and you go back to that front page where I have the summary judgment panel, I come to the conclusion based on all the data that we have indeed detected a change in heat waves and they are increasing. And that's consistent with what the IPCC has found. One of the things I hope this site allows people to do is to identify the cherry pickers out there. Um, for a lot of these variables, you could probably go out there and find something that aligns with what you want to believe. Um, but when you put everything together, it's very hard to argue against what the data says.
And when you say you're concluding that there's a change in heat waves, in terms of you're comparing a change from does this mean that there's an upward trend in heat waves and that's based upon going back to what years? This starts in so for heat waves, this starts in the 50s, right?
Right, exactly. Yeah, so I apply the IPCC criteria for detection here, and there's basically two requirements. One is that there's a trend that's detected in the time series. And I only use a time series that's judged to be of reliable record. Um, you can go far back in time for some variables, but there's not good coverage. They didn't have good instrumentation. So I'm very clear as to what the community thinks is the reliable record. So the first criteria is there's a trend, and you don't have to be a statistician to look at that graph and say, yeah, it's going up. And the second criteria is, does that trend exceed what we would expect through just natural variability? And admittedly, that's a judgment call. The IPCC does not have a formal criterion for that. It varies phenomena by phenomena. On that graph, I shade the 66% range of historical variability and the 90% range in the lighter gray. And so if it exceeds that 66% range, the judgment call here is that there's been a change.
So where does this number, going back here, just trying to figure out how this looks, like what does this 8.8 days refer to?
So that refers to the warm spell duration index. And so you can go to that page and understand how it is compiled, but it's basically the number of days per year across the country for which there is what's defined as a warm spell of a particular duration. It's a technical metric, and it is think of it more of an index rather than something that you or I might feel where we live. It's a national aggregated index. So it's not heat waves are a lot more complicated to characterize than say tornadoes.
Because tornadoes, yeah, we can just count. There was a tornado.
Well,
right?
and drought is similar. Drought is similar. There's different ways to measure a drought. There's hydrological drought, which is think of water flowing in a river. There's meteorological drought. Think about rain falling from the sky. There's soil moisture deficits. So think about how dry the soils are. And then drought, if you want to look at spatial extent, how where it covers and so on. So some of these metrics are more complicated than others and require the use of indices. And then when you're aggregating over a land mass as big as the United States, it becomes even more complicated because what happens with drought in the southwest of the U.S. is going to be very different than what happens in, say, New England.
What I really appreciate about this, Roger, is like you're sort of explaining, like it is wonky, right? Like this is sort of
Super
and it's a
wonky,
work.
yeah.
Yeah, it's a work in progress. But the point is that like you can sort of figure out how you come to the conclusions. Like it's all put there, and the source of the data is available and whatnot. So, and you have sort of a top line summary here, which is that like heat waves, you detect a change. So if somebody wants to come to this, if you read in the media, some newspaper report says that there is an increase in heat waves in the U.S., you would agree with that statement. The question then becomes like, how extreme is this? Or I guess when you say there's a detected change in heat waves, if I'm looking here at this graph, maybe the simplest question is, should I be concerned?
Yeah. So the first thing to say is that concern is it's a value judgment that people can make based on their own, worries about risk and whatever else they go on. For people who have uh, available air conditioning and they're not in a profession that's heat stressed, they probably, it's an annoyance. But overall, for the economy, for ecosystems, for people who um, work outside, yeah, we should be concerned. Um, and this is a manifest. This is probably the extreme weather phenomena. Not probably. This is the phenomena that the scientific community has the most certainty in. That is a result of increasing greenhouse gases. And it's not just in the United States, it's elsewhere around the world. But yes, heat waves are increasing. Um, and I don't think that'll be a surprise to many people. And yes, it should be something that we're worried about. In Europe this summer, there's a huge debate going on over air conditioning, which to the American ear is sounds kind of ridiculous and silly, but and part of the change in the European climate is due not just to greenhouse gases accumulating in the atmosphere, but also the reduction of aerosols. There's some really good recent research that suggests that as we've cleaned up the air, it has led to the drying of soils in Europe, making heat waves uh, worse. And so, yes, that is something that we should pay attention to, and adapting to increasing heat is something that we should be paying attention to. Now, if you're in Phoenix, you're pretty well adapted to heat because you're used to living in one of the hottest places in the country. But if you're in Portland or Philadelphia, um, that those communities might need to pay more attention to adaptation, say, than Phoenix or Miami.
So the key thing here, and that use of the word concerned, I guess that's sort of just baked into my head, really, because when we talk about climate, we're really talking about what do we need to do about this, both societally and then like in our daily lives, right? And so getting at really what changes in the climate are going to have the most impacts, or like what really is changing in the climate, number one, and then how do we adjust our lives or society to address problems that arise is really what's important here. And to your point about Europe, the last episode we did was about how the policies in Europe on air conditioning cause people to die.
Yeah, I mean, again, this is another place where nuance creeps in. I tweeted out in the last few days, Tom Steyer, who ran for governor in California, previously ran for president, billionaire, um, who funded an effort to get me fired, but that's a separate story. But Tom Steyer gave a speech in where he said that we have to reduce emissions in order to stop heat waves and stop hurricanes. And I want to be very clear that I'm a supporter of emissions reductions, but there's not a emissions control knob on extreme weather. It doesn't work that way. We reduce emissions, and that reduces the risks of future changes in the long term future. But if you're concerned about losing lives in heat waves in France or in Philadelphia or wherever, reducing emissions is not going to affect the lives of people today, or tomorrow, or our children. That's not how it works. Air conditioning, cooling centers, um, better adapting to the changes and variability in climate that we expect and that we've observed. That's how we protect human lives. So the climate movement got off track, I think, when they started promoting emissions reduction as a weather control knob. And again, I see this almost every day, that the idea that if we reduce emissions, we won't have bad weather or it won't be as bad. And it just doesn't work that way.
So going through some of these other things, let's thank God, Roger, tornadoes are not changing. I was always fearful that I was going to be swept away in a tornado, having watched Wizard of Oz as a kid. I'm always afraid of that, but luckily, so just okay. Jokes aside, so the tornado data now. This only goes back to a little bit before 2000, right? So in terms
Yeah.
of the
Oh,
so
go ahead.
there's no, I was going to say, so in terms of the different um, weather events that you're tracking, some of them have data that goes back, into the 50s for heat waves. But here, this is like, we're just saying over the last, 30 years or so that we've seen no changes in tornadoes.
Yeah, so there is tornado data available that NOAA has back to 1954. We wrote a paper on it, but over time there has been important changes in how we observe tornadoes. So Doppler radar, for instance, is a technology that was started to deploy in the 1980s and gave much better coverage. It used to be back in the day that tornadoes were counted based on if people saw them or if they caused damage on the ground, not if we observed them, say through a radar. So there is a longer term record of tornadoes. One thing, I mean, again, this gets to the nuance. If you look at the weakest tornadoes, there's a really sharp increase, but that's because we detect more of them. And if you look at the strongest tornadoes, what are called EF4 and EF5, there's actually evidence that they have declined, not on long climate timescales, but maybe over the last 10 or 20 years. So the overall judgment on tornadoes, again, consistent with the IPCC, is no detectable change, even though there are some nuances there. Another nuance is that where tornadoes form has moved from Tornado Alley in Oklahoma and Texas further to the east over the last few decades. And there's a lot of discussion and speculation. Is that just a variability thing? Is there a reason behind that? All of that is just to say that for tornadoes, there's no strong evidence of a detected change.
Okay, and then similarly, so you have that no detected change for flooding, drought, winter storms, and hurricanes, but you're seeing cold extremes and wildfire area, you see changes. And in fact, you see the opposite, of course. So cold extremes are going down and heat waves are going up.
Yes.
Um, and the cold extremes, let's take a look. That goes back. So again, yeah, so this data is going back into the same region of time, the same time period as the heat wave data.
Right. And it's the same data set, just the other end of the thermometer.
Let's talk a little bit about the logistics of how you did this project. You relied on some AI tools, right?
Yeah. So let me say I do use AI tools. I would say I'm a power user at this point. They are incredible. It is game changing for researchers. Um, and I'm going to give a shout out to my colleague Ryan Maui, who runs a site called Weather Trader, who gave me a boot camp in getting up to speed on using and deploying Cloud Code. So thanks, Ryan. The tools allow for the manipulation, assimilation of enormous amounts of data. So as I said, the paper we did in 1999, I'm not exactly sure how many variables we covered. It certainly wasn't 38, but it took a long time to collect that data, to process it, to graph it, to assess it. Um, this project took about a month, um, and the amount of data that is displayed on this dashboard is incredible. I just can't. If I had my estimate would be if I had a team of 4 postdocs, and you gave me a year or 18 months. Um, 5 years ago, I could have done something similar. This was done by one emeritus professor sitting in this room. So it is an incredibly powerful set of tools. And this is nothing. I'm about to roll out a new global extreme weather site that has 286 variables. And the amount of data that you can process quickly, the literature you can assess, it is a true game changer for science. And uh, it's as the IPCC goes forward in assessment, being able to use AI tools for quantitative and programming tasks is going to change how we do science. And so this for me is it's a whole new world.
With respect to the use of AI, how do you um, make sure that there weren't any issues like the AI messed up the coding or did some analytical error?
Yeah, and I mean that's a real concern. I mean hallucinations are a reality. They are less problematic than they were maybe 6 months ago or a year ago in the use of AI tools. But to be honest, I treat AI exactly the same way that I treat HI. If I had my human intelligent team of 4 postdocs doing the coding and coming up with results, I would do the exact same thing. Is you double check, you triple check, you ask one person to check the work of another person. I go through and myself carefully compare the data to what I know is being reported. And I can tell you, after I put this site out, I realized, just looking at the numbers, that the tornado number that was presented was slightly off from that the Storm Prediction Center was publishing. And so you go back to your agent in Claude Code and you say, "Look, I see a discrepancy here. Go investigate that." And then the agent comes back and said, "Yeah, we were double counting storm reports for this particular region. That's an error in the code, and we're going to fix it." So, um, are there coding errors or small mistakes in there? Sure, probably. Would there be if I had my team of postdocs doing the same thing? Yeah, sure, probably. And the key is to realize that this is a living, breathing product that can be incrementally improved. And so I encourage people, if people look at something and say this isn't quite right, I have another dashboard I did on decarbonization, and that one's I've had a lot of feedback from people, and people think they found errors, and they let me know, and I go through and check, and having that sort of peer review, extended peer review, is very useful. Um, and if people say, well, your 38 variables miss, these other variables, they can be added. There's no real limit to how deep we can dive on this. But as far as the areas, for better or worse, I know a lot about extreme events because I've been doing this work for 30 plus years. Um, the results that this site presents, number one, they're consistent with the data and literature as I have come to understand it, and they're also I have a consistency check. You'll see on that first page, um, at the top, under detection and attribution, I have a consistency check with the IPCC. That's kind of a look at, do these results match up with what the IPCC has concluded? And there are no inconsistencies. Um, I go some places the IPCC does not, such as wildfires. But overall, I'm pretty pleased with the scientific quality of the effort.
Now, while we're talking, I actually realized maybe there's a point, maybe the Trump administration has a point, which is that you've done all of this and you've done it, from a room by yourself with AI tools. Government is extremely inefficient, right? Like government work, like you could have 1,000 people that couldn't produce this in years, right? Due to some bureaucracy. So correct me if I'm wrong. Is there some potential? Maybe it is okay that governments aren't putting resources like this on government websites, especially given a lot of people don't trust the government. So can we go back to this point a second ago that we talked about, where there were things removed from the EPA websites? They removed data or analysis or both?
Both.
Where did that data go? Is it no longer publicly available, or you have to search for it in different places? Or
You have to search for it in different places. You have to know where to look. You have to know how to process it. It's in machine readable formats, not in human readable formats in many cases. And I would analogize this to economic data. If we want the U.S. economy to go, then we need someone to play the role of an honest broker in providing data that can be trusted, that is not corrupted. And this administration has had some troubles with economic data, like Bureau of Labor Statistics and so on. And I would put climate and weather data into that category. Nobody wants some emeritus professor being the one that presents the data on extreme weather. Um, think about it like this. So when COVID first hit, a couple of journalists at the Atlantic created a dashboard on COVID occurrences, and I would much rather have a trusted official government body providing that information rather than a couple journalists at the Atlantic. No offense to the Atlantic. So, but the key there, it has to be trusted, and it has to be worthy of the public's trust. And so this is where I think the institutions of expertise that provide this sort of data have really atrophied in the United States. And the very fact that we would have a discussion, can we trust the government to provide this information? And I've written extensively to how the Biden administration, the Trump administration, and going back all the way to Clinton, every administration has played with climate data as a bit of a political football. And do I trust the National Climate Assessment? No, not for a second, because of where it sits in the White House. It's just too tempting a target for political operators to put their thumb on the scale. So figuring out how to create institutions worthy of our trust um, should be a big project, not just for climate, but for economics, for labor data, for other data, health data that we would expect. One of the basic functions of government would be to provide accurate information.
Is sometimes data is not reliable. Sometimes data is, garbage in, garbage out. So if the data is presented and how the data was collected is as accurately described as possible, that's the ideal situation. And I agree with you that if certainly if a government paid to acquire that data and taxpayers paid for it, then it would make sense for that data and the way it was collected to be available on a government website. Trust or no trust, that just seems like logically the thing to do.
Yeah.
Then you get into all these other issues. Like you say, you have the economic data, if it doesn't, help an administration, if it's bad politically, blah, blah, blah. So I guess at a higher level, I agree with you. But then getting into sort of the nuances of like what one administration does and another, you need multiple sources of people doing things in order to really get a complete picture. I don't think you should just blindly trust people anymore. I think we learned that's a mistake. Even people operating in good faith make mistakes. And so placing your trust in people is not the best approach generally, without doing some verification, especially on very important issues. And the climate issue is extremely important because we're talking about policies that change everyone's lives.
I appreciate and agree with the sentiment, but in 2026, it is impossible to go through society um, and function without blind trust. And I'll give you an example. You and I fly a lot. You get on an airplane. Um, you do not verify the air traffic control procedures. We don't verify the weather data collected that goes into the aviation routing. We have blind trust that we're going to get on that airplane and then when it lands, we're going to get off. And that's because of expertise in alphabet soup of government agencies with private sector contractors and support that make our modern society go.
Well,
Now,
hold
there are
on,
some
Roger. Hold on a
yeah.
second there. With the airplane one, I don't like the airplane analogy because that to me also, you're ignoring the incentives. And the incentive is that pilot wants to live. And the largest incentive to, is life itself. And you're going to have pilots that can perform the task without killing themselves. That's going to be selected for. So I don't, sure, that happens and we trust the pilot and all that to work. But at the same time, everybody involved there has an incentive to make that work because if they don't, we're all dead.
Yeah, well, it's not just about the pilot, it's about all of the institutions.
They'll get sued, right? There's a lot of like they're monetary, there's reputational stuff. Incentives drive outcomes. And so here, politically, there are incentives to bury the data. Sometimes this is the economic data. There's a huge incentive to say if the economic data is bad and is politically bad, we don't want that, right? So I don't know. Trust is use. I think we can trust certain things. I agree. Like we do want to blindly trust certain things because kind of it makes sense. We kind of have to. Like our brain will be
Right.
overloaded. But to get I don't. But it doesn't extend. It extends into some areas and not others. I guess is where I disagree. And
Yeah,
I
I
don't.
agree. I mean, it is nuanced, and there are some areas. I mean, issues that are more focused on, let's say, science than technology. I mean, technology has to work, right? The airplane has to fly. We can argue about what the temperature of the Earth's going to be in 2100, and it really has no practical implication for today because we can't resolve that debate. I mean, this is one where I think if the U.S. government were to take on, let's say, this extreme weather dashboard and present all the information, trust is built by allowing people to show your work, show the data, allow for challenges, recognize nuance and contradictions. Um, and we don't do a particularly good job on that in the climate area. I will say weather data, that's picked up and used in forecast models and by air aviation and in agriculture. So far, fortunately, that hasn't become politicized like climate data has been. And so we should try to work pretty hard to keep it that way because everybody depends on accurate weather forecasts.
Don't give anyone ideas, Roger. Now you just planted the seed in people to start politicizing that stuff. Oh boy. One more time, do you want to make sure that you explain that you're launching a global version of this, right? Just to clarify.
Yes, I am launching, maybe even by the time people are watching this, a global version, a global dashboard for every continent, 286 variables for tropical cyclones, tornadoes, floods, drought, wildfire around the world. And so if you're curious as to what the data says on trends in these extreme weather phenomena, um, go to thehonestbroker.org and you can access all of these dashboards, there's a growing family of them. And my goal is to have a higher quality conversation about weather and climate than we typically get from the mainstream media.
And that's why I like doing these shows with you, these episodes with you, because I do believe that you are, fitting. Your brand as Honest Broker is appropriate, and I appreciate your efforts in this area. And we disagree on some things very clearly, but also at the same time, I think you're operating good faith. Good faith, that's it. And you show in your work. So I really appreciate it. So thanks a lot, Roger, for taking the time to talk to me and go through this dashboard. And good luck with the launch of the global version of it. That's going to happen very soon. And until next time, this has been Bryce Nickels on Science from the Fringes in defense of climate change. Take care, everybody.